A customer sent in their Vizio power supply. It is completely dead. There's no power at all. This is for a D55UN-E1. So we're going to do a component level repair and show you exactly how we fix it. The first area we're going to take a look at is the front of the board, and it's going to be right over here. I've already been pretty thorough on this board and marked all the damaged components. So the first one we're looking at is this one over here, C9100 is defective. We're going to have to replace that. We have the resistor over here, R9111. As you can tell over here on this side, there's a burn on it. We have Q9100 here that is shorted. And we'll do some multimeter checks here in a second. And finally, if we scooch over here, we have C9801 is another capacitor. Now this one is not actually damaged right now, but if we don't replace it, there's a high chance that it will fail in the very near future. So we're gonna go ahead and replace that one as well. Now for this capacitor, it's very obvious that it is very damaged, so we're not gonna do a measurement on it. But for R9111, normally that is a 33 ohm resistor. And currently, if I do a resistance check, we're getting, let's see, 25, 30 kilo ohms rising. We have our transistor over here, Q9100. When I go in continuity mode, we get a beep when we have a short. And if I measure the outside pins to one another, I have a short. That resistance should be about 10 kilo ohms. And the reason for is, if we flip the board over, we'll notice the resistor right over here, 1002, and that is a 10 kilo ohm resistor, which currently it's reading shorted, but that's because the transistor is actually defective. Okay, now that we are on the back of this board, we're gonna go ahead and look at some of the components that I have failed here. We have this IC chip U9101 that will need to be replaced. We have the diode D9103 that is typically damaged. Now, it is supposed to have a low reading, so it's not actually shorted, but same as that capacitor on the front, this diode will commonly fail. All right, and then here we have two resistors that you can see clearly. There's a little burn mark in the center as well as across here. This first one is supposed to be a 10 ohm resistor, and I'm getting an open reading. And this one's 82 ohms, I believe. And same thing, this one's completely open. All right, let's take a look over here. We have another one, R9103, and that's supposed to be a 47 ohm resistor. And same thing, it's reading open, and you can clearly tell right here, there's a little burn mark, visually indicating that it is damaged. Now, if you're interested in performing the repairs yourself, we do have all of these components that we've outlined as defective available for sale as a repair kit. That'll be on our website, and that'll be linked in the description down below. If you want us to fix the board for you, we'll also have a mail-in service available where we can do that repair for you, and that will come with a 1-year warranty. Let's begin. All right, we're gonna start by unscrewing the transistor. Next, we're going to flip the board over, and we're going to go ahead and desolder the transistor from the back. I'm going to start by first adding a little bit of new solder to all 3 of the legs. And using our desolder pump, we're going to go ahead and remove that solder. Now, if I did my job correctly, all 3 of the pins should move, and they do. So that means we should be able to push the transistor through. There we go. Now it's free and clear. Okay, we're back in continuity mode. So when we have a short, we get a beep. Let's take a look. Are these 2 legs shorted? And they are. Now let's recheck the board. Do we have a short? And the short is gone. I'm gonna go to our resistance mode, and we should get 10 kilo ohms, and we do, 9.99 kilo ohms. Now before we replace it, let's go ahead and remove the resistor R9111 and the capacitor C9100. These over here are the 2 legs of our capacitor. It looks like I got the majority of the solder, but not all of it. So let's finish that off with the desolder wick. And I can tell that the capacitor is now loose, it's able to move. Let's do the same thing with our resistor down here. We'll add a little solder first. Now same thing. Let's finish that off with a little bit of our desolder wick. Okay, there we go. All right, so now we should be able to remove these from the top. There we go. There we go. All right, next we're gonna go ahead and take care of capacitor C9801. Same deal, we're going to add a little bit of extra solder first. And do we have movement? We do. Okay, and there we go. So that's going to complete the removal of all of our through holes. Now for the removal of our surface mount components, we're going to also add a little bit of solder to all the legs. But then for the removal, we're going to use our hot air. I'm going to use the soldering iron in tandem to give it a little help. And some of these are glued, so you're going to have to put a little bit of oomph in order to remove them. So the reason I'm putting that extra solder first and then giving it the quick assist, there we go, is because there is some glue holding down these components. And I want to make sure that my traces are flowing. I don't want to accidentally rip a trace. All right, and now while my board is hot from the hot air, we're going to go ahead and remove all that extra solder. It's just easier to do that when the board's still hot. All right, we're going to clean all that up with isopropyl alcohol and a Q-tip. To get started on the reinstallation, we're going to add a little bit of solder to one side of each one of these components. Just like that. Then we're going to go ahead and melt that side. Slide our component in. Lock in the other side. And we're all set. We'll go ahead and do the same with the IC chip. Make sure it's lined up right. Now we can lock in a couple of the other legs. I'm going to add just a little flux to make it nice and pretty. Probably don't need to, but I also want to make sure we have really good flow between the traces and the pins. There we go. Now the diode, same thing. Melt one side, slide it in. Now it's locked in. Now for this one, I am rotating the board just a little bit. Next, we're going to install our replacement capacitors. Now I am holding it with one finger on the top side, and I'm going to be bending the pins out so that the capacitor doesn't fall out. And we'll do the same with the other one over here. Feed it through, hold it down. And lastly, we're going to do the same for our resistor. Now we can go ahead and start soldering all of our through-hole components. Okay, and now we'll want to cut off the leads excess. All right, and finally our transistor. We're going to go ahead and clean off some of the old thermal paste. And we're going to go ahead and put our new thermal paste on. And that is probably too much, but that's okay. Let's do a final check. Do we still have a short, or do we get our 10 kilo ohms still after replacing the component? And we do not have a short anymore. So let's do our final testing. We're going to go ahead and plug it in. Let's see what voltages we get here. We're getting 168 volts. Let's go ahead and power it on. And now we're getting 356.9. Okay, let's do a check on our 19 volt lines over here. And we are getting 19 volts. Let's go ahead and unplug it. We're going to go ahead and discharge the power supply. Now this does confirm we have another successful repair. If you're interested in getting more information as to the location ID and types of components that we replaced here today, I will have a post on our Facebook page detailing all of that information. If you want to buy the repair kit, we will have that kit available in the description down below on our website, as well as the full repair service where we can go ahead and repair this power supply for you. If you found the video helpful or useful, make sure to leave us a like, subscribe for more content, and thank you for watching.